AVM. In fact, its original use in the early 1990s was for the AVM to be used in the domain of software testing. It might be used, for example, in the area of regression testing. It might be used to automatically generate test data. But the point is, again, the alternating variable method is frequently used in software testing tasks. Also, you can find the AVM used in various types of software product lines, research, and development. Again, the key takeaway point is that the AVM is used in a very wide variety of different application domains. Now, I'd like to take a moment to very quickly walk through how the alternating variable method works in its simple understanding. You're going to start with an input vector. Let's call that x, as I'm indicating on the middle of the screen, and it will be comprised of variables x1 through xn. You can think of those variables x1 through xn as like inputs to a method or inputs to a program under test. Now, what we're going to do is to take that input vector and feed it into an objective function. The purpose of the objective function is to give us a way to know if our search is heading in the right direction as the AVM is running. Now, the AVM is going to perform a series of what we call exploratory moves. Those exploratory moves are intuitively big jumps, helping us to know whether or not the search is moving in a positive or a negative direction. Now, let's say, for example, we want the search to move in a positive direction and is, in fact, doing such a thing as the AVM operates. In this situation, the AVM is going to then start to perform a series of pattern moves. These pattern moves are smaller tweaks to the input vector in the hopes of further improving the objective function. Now, the question is, again, is the pattern move improving the objective function or not? If we can answer yes to that question, then it would behoove us to continue to perform a series of pattern moves. To continue to explore and do some of those bigger jumps with exploratory moves. This process in the AVM, alternating between exploratory moves and pattern moves, and once we've done that, we're going to ultimately apply the AVM approach to all of the input vector variables. So now you can see we move from one variable to the next variable, and we're going to continue working on each variable as we try to come up with the best possible test data. Now, of course, there may be some situations in which the AVM gets stuck at a local optimum. When that happens, we're going to have to restart the search according to various standards, such as a random restart. It's also possible for the algorithm to continue until some termination condition is met. That might, for example, be when the search has become quiescent, or when we've operated up until a fixed number of iterations for the algorithm. Now that you understand a few of the basics of the alternating variable method, I want you to realize that the algorithm has been pretty much in the same state since 1990 with some small modifications. Until recently, there was a paper published in the Theoretical Computer Science Journal that proposed some new ways to improve the AVM algorithm. So one of the things that they suggested is that they should use a type of geometric search instead of the standard iterated pattern search that we've used frequently in the past. Also, it's possible to use something called a lattice search. There are details in the paper I'm presenting if you'd like to know more, and you can also look at a theoretical computer science paper to get all the details. The key idea is that these two techniques are going to use past moves in order to bound the input values for the variables, hopefully allowing the search to proceed more rapidly than it would otherwise. One thing that's nice is that we would hope to have one full implementation that has not only the geometric approach, but also the lattice approach and the standard IPS that has been associated with AVM for many years. One thing that I want to stress, and you'll see on the bottom of my slide in blue, is that there are now better search algorithms that can handle a wide variety of different landscapes. And in fact, the geometric search and the lattice search are provably faster for unimodal landscapes that you might see in certain kinds of test data generation problems. Now that I've talked about those innovations, I'd like to transition to one additional new innovation, which is the representations that can be used for the alternating variable method. AVM was initially proposed just to handle integer data. But there have been recent developments that would allow it to handle, for example, decimal data or character and string data, and then that would hopefully, with one combined solution, allow us to handle numerous different data types, ultimately being able to apply AVM to real-world programs. Now, I should stop on this slide to say, yes, it would be important to apply it to programs, but we'd like to be able to apply it to a wide variety of other kinds of artifacts that need, for example, testing to be applied to them. For example, we might want to apply these innovations of the AVM to things like relational database schemas. Let's transition on, and I want to talk briefly about what you might do if you were going to yourself implement some of these new AVM innovations into your own tool. Well, if you're like me, you might start with some of the existing implementations of AVM. And when you look at the source code of those systems, like the ones that I'm presenting on the screen right now, you might say, do the existing AVMs handle all of the data types that I'd like to handle? And sometimes the answer to that question is no. Additionally, you might ask yourself the question, hey, do existing AVMs provide all of the search methods that are provably faster for unimodal landscapes? And sadly, I found the answer to that question is also no. So the key point here is that prior AVM implementations lack provably faster methods, and we'd like to be able to bring those into the mainstream so other people and researchers and developers can use them. Now, after addressing that key challenge, let me talk very briefly about some tools that use the alternating variable method. One big area is test data generation. And in fact, there are numerous tools that have used an AVM or something like the AVM in order to generate test data in an automated fashion. For example, the Austin tool generates test data for C programs. The EvoSuite tool is able to generate test suites for Java programs. And the Schema Analyst tool is able to generate test data for relational database schemas. All of these tools use some type of AVM. And so if you were really interested in using an AVM, another thing that you might do is say, well, I know what's next. I should try to extract the parts of the AVM that are important for me from existing systems, and then I can have my own AVM. And so, for example, if you look on the screen, I'm now showing you some examples of source code. If you were to look into the source code and try to say, what's the part of the AVM that is responsible for computing fitness, it might be difficult to find it. Additionally, you might look at the source code and say, what's the part that is responsible for performing the search? And in many of those cases, it takes a long time to actually realize that the fitness function is hiding in that magenta line of code at the top, or the search function is spread across multiple files inside of an existing system. So I think we've now come to the second key challenge that is associated with using the alternating variable method. And the challenge is as follows. It's really hard to extract an alternating variable method from customized software that is already specialized to a certain domain, like C programs, Java programs, or database schemas. So the question is, if I can't find a system that has the newest methods, and if the systems with the newest methods are really hard for me to adopt for my own domain, what should I do? And today I'm delighted to present you the answer to the question, what should I do? I'd like to present a solution that is called AVMF, or the Alternating Variable Method Framework. AVMF includes original AVM functionality that many of you may have used in the past. It includes a number of key enhancements for both data types that you may want to incorporate into your search. It includes both geometric and lattice search techniques that are provably faster. What I want to stress about the AVM is that it has clear implementations of the core algorithms. The algorithm is the pseudocode of a paper. You clearly see how that pseudocode is represented in the Java implementation of AVMF. Nice about AVMF is that it was implemented in the Java programming language, the principles of good object-oriented design. If you're comfortable with object-oriented design, if you know the basics of programming in Java, you'll be able to look at some simple AVMF examples and get up and running with your own solution for your own problem. Now, in addition, I want to point out that the AVM solution that I'm presenting today is now available as free and open source software. My colleague Phil and I would love for you to go to avmframework.org. You can download the tool, you can use it because it is licensed under an MIT license, and you'll be able to begin using this free and open source system in your own AVM software. Now, the other point that I'd like to stress is that once you've gone to AVMF and you've downloaded our tool, you can start to do several exciting things. The first thing that you can do is to begin applying AVMF to new application domains. For example, maybe you're interested in testing databases or websites. Maybe you're interested in software product lines or requirements engineering and analysis. The system that we've developed comes with numerous examples, and it will allow you to apply AVMF to a new application domain. What to do after being rescued by the AVMF solution is for you to actually implement your own search algorithm. For example, you may be interested in implementing a mimetic algorithm which might combine a global search with a local search. In that situation, you could take AVMF and the existing implementation available on GitHub and combine it into a completely new search algorithm. Now, at this point, I'd like to very briefly talk about the design of AVMF, and then once I've done that, I want to show you a very short demonstration and then open up the room for questions. So AVMF has several key modules. I can't go into the details of the modules today, but you can read our paper and learn more about the way we've designed and implemented the system. The configure module, which you'll see I'm projecting on the left-hand side of the slide, is the module that allows you to pick what kind of search technique you'd like to use. It allows you to say your termination condition. Overall, it allows you to specify how you want the AVM algorithm to actually run. There's another core module of the system, which is the representation. This is where you can set up how you'd like to represent integer values, decimal values, character, and string values. We have all of these available to you out of the box, and you can configure how they're represented in your own AVM solution. AVM also has two additional core modules, which I'd like to briefly introduce. The first module is the one that provides the objective function. This gives us the ability to, out of the box, easily calculate higher is better or lower is better metrics. All you have to do is to provide, say, a 5 or 6 line function that will calculate the objective function, and we fully integrate it into the system for you, allowing you to easily perform a search. And then finally, there's an additional module built into AVMF. It's the reporting module. This allows you to see how your search performed. You can see how many objective value function evaluations there were. You can see the final input vector that was optimized, and you can get other diagnostic information about the efficiency and the effectiveness of your search. Now, with those things in mind, again, you can look into our paper for additional details. And finally, I would really encourage you to go to the tool's website because it contains extensive documentation that I'm not able to present in this session today. For example, we have tested AVMF on multiple operating systems with multiple versions of Java compilers and virtual. And what I'd like to do now is to just show you a tiny bit about how AVM, the system, actually works. So in order to do that, I've prepared Now again, the demonstration is set up so that I've already run the git command, which would allow me to clone the environment, and then I've also run the maven command to build the system. On the screen, you'll see some of the source code for AVMF. This is the quadratic example that is mentioned in the paper. What it's doing is a very simple root finding function where it's going to find the roots for a function that is defined with the values for A, B, and C that you see at the top of the screen. Now there is a function that is the objective function that just scrolled past a moment ago. And then finally, there are the output details for the system that are appearing at the bottom of the screen. Now, I know it's hard to take in source code as it quickly scrolls across your screen, but one thing I want to note is that that simple example was only 82 lines of Java source code, including comments. Now, I'm beginning to run several examples. You can see the first time I ran the quadratic example, and it found one of the roots. I then ran the geometric search, and now I'm running the lattice search, and in both of those examples, it actually found the other root. You can see diagnostic information that shows how long it took to run the tool. Now, I'm running at this point the string optimization example, and you can see in that example, it was trying to find the string AV, alternating variable method. It ran that string, and it found it accepting one letter and got an objective value of 0.9875. The final example that I run here at the bottom of the screen is actually showing that AVMF is suitable for generating test data for many real-world examples. For example, if you look at the bottom of the screen now, it's generating test data for a calendar example. I've specified that I wanted to generate test data for branch 23 of the program, and I've asked it to try to exercise the false branch. Now, again, there's several key points that I want to stress about the presentation, and I'm going to go in the following fashion. First of all, the AVM that you saw ran a quadratic example. There are details about that in the paper. There was also a built-in string example, which you can run when you go to avmframework.org. Finally, AVM Framework comes with an example to generate real-world test inputs for real-world programs, and you can try that out as well. You saw in the demonstration the input and the output for the tool, and you might have noticed that it had stochastic behavior. It didn't always arrive at the same answer. If you want to use the tool, you'll first have to run the get clone command and then build the package using the Maven package builder. Now, as I conclude my presentation, I'd like to, number one, thank you for your attendance and your attention, and second of all, make three quick points. First of all, the tool that I'm presenting today, AVMF, is designed to overcome the challenges associated with using AVM. Second of all, it has algorithms built into it that allow you to do provably faster searches and allow you to generate data for new data types. It has an accessible object-oriented design, which I think you'll find easy to understand. The algorithms are clearly described in the system and is in fact open for you to download at avmframework.org. At that, again, thank you very much, and I'd like to turn it back over to our session chair. Thank you. Can you speak really loudly because I have a cold? Oh, that's a very good question. The answer to that question is, at the moment, no, AVM Framework has not been integrated into EvoSuite, but there would be nothing that would prevent us from collaborating with EvoSuite's creator and allowing us to put the tools together. That's a good idea, and I think a great suggestion for future work. Why Java? Oh, that's a very good question. I think in part, Java was a language with which we felt comfortable. It's also a language for which there's a wide variety of case study programs that we can apply to. One of the things that we'd like to be able to do down the road is to, for example, show that we can generate test data for the real-world programs that are in defects for J, and then show that our tools can actually, for example, detect the real faults in the defects for J repository. Okay, thank you very much.
He's the next speaker. Yes, sorry, he's the next speaker.
Yes. Okay. So the question was, how do you actually go about combining the search techniques? And what you would have to do is to allow one of the methods to interact with the other methods. It's actually extensible, so you can customize the steps in the AVM search, and you can hand off to the other algorithm at one of the points in the source code. So there's more details that you can look at, and later on, Phil or I could give you a tour of those details.
Hi, everyone. My name is Arya Bharat, and I'm here to talk about um, an improvement in genetic algorithms in software testing. The paper title is the Network Dependency Relation Guided Genetic Algorithm. My presentation will start with a little bit talk about the automatic test generators that are available, and then talk more precisely on the genetic algorithm and how it works. Some problems that face the genetic algorithm and how that we use the method dependency relation to overcome some of these problems, and talk about how did we implement the method dependency with the genetic algorithm itself for generating such data for object for Java language. Then some of the evaluation and feature work. There are many automatic test generation approaches. The most famous one is random testing, where it's randomly generates sequence methods and constructor identification for the class under test. The random testing is easy to implement, applicable, and it's very fast. Just generate and execute, generate and execute, either to cover all the branches if it's that you code, or you until the given time limit. However, random testing faces challenges in producing a sequence method code with specific arguments for complex programs or complex class under test. So it's very hard to generate some sequence methods and constructed in specific order that you need to hit that or to cover particular branches. Another way of genetic testing is using the symbolic execution, where we explore all the best conditions in the program under test and select constraints, and these constraints goes to the constraint solver, and if that batch is feasible, to be generate input for them. However, it's still this approach challenges scalability if the program is very large or complex. The other type of the approach is the set-based software testing. Here is the problem of test data generation is converted as to a set problem, and then implement either any technique, search technique like lining or MEM or genetic algorithm. And the effectiveness of this technique is improved as long as the fitness function can distinguish between good and bad or worse solution in the search space. The genetic algorithm it starts with the initial population, which is randomly generated. Here the population is test cases, and all the set is randomly generated. Then it goes to the each individual is evaluated, being executed, and each individual is evaluated for fitness. Then goes to the selection stage, where the parents of reproduction based on their fitness being selected, to the crossover stage, where the two selected individuals let's to candidate individual and mixes the resulting parts to form two offspring. This new individual go to the mutation operator, where it's there can be mutation applies randomly modification to the content of the offspring, and then goes back to rebuild our new population, and this iteration can be iterated until either the optimal solution found, if you are shooting for cover, branch coverage, all the branches are covered, or it's your time is up. So some problem that we notice during our experiment is the control and data dependency. In this class, if you see as an example, in this class, it's taken from the NanoXML project, and it sees it's only contained 4 public method. However, if you see one of the methods, all these parameters are not affected. Any branches here, target branches, are not affected by any of the parameters. But if you look closer, it's affected by a field that is being modified. It's an object being modified in the construction of the class itself. So it's kind of, it has, you need to cover such branches, you need to have a sequence ordered for your test cases. So it's when we, as I said, as revealed by our experiment, pure random testing and search-based approach in suite could only achieve 69 and 68 branch coverage of the C data reader class respectively. Another problem that we noticed it's the input domain size. So here, if one other class that we noticed it's taken from the common line tree called the array uter. This class contains 228 public methods. And each method most likely contains like 3 parameters, either an array and 2 integers. And also, some of the branches are involved with the null value, which means it's a flag problem. Here is the fitness function is like blind. It's not giving you any guidance to the search. So when we run the EBSuite and random, we got really high coverage in the random, and in EBSuite it's very low coverage, which is unsurprisingly here because it's, as we said, it's almost each all the 228 method. It's like there is no need for order the sequence. It just needs to generate like null value for the array or the array with any type of value. So can we do something to improve such search phase to get to avoid such a problem? We statistically analyzes the each target branch, and we figure out if there is any what's affect these branches. For example, in this target branch P1, we statistically identify there's only the reader it can be affect this branch. And when we go back, we find out that C data reader is right that field. And also we found to best the parameter of the constructor of C data reader is require an object, and there is a method from other class can provide such an object. So we figure out there is some relevant part of all the class, either method or a constructor can help to cover such branches. So we make it like more constrained. So in overall, this is the general framework. We take the class under test, and then we instrument that we collect the information about what we can test, and we instrument the fitness function, and then this after the instrumented class, we do the genetic algorithm on that instrumented class. And our genetic algorithm is targets all the tries to cover all the target branches at once. It's not target by one at once, like the same technique that EBSuite does. And we do this fitness function that collect the branch densities of the uncovered branches. However, we add more static analyzer while we are instrumented to figure out what, as I said, which field that or a parameter that for each target branch, and then we we figure out we use the NDR to find all the relative methods and the construction for each target branch. And during the genetic algorithm, instead of during the mutation operation, instead of just randomly change or add a method call or a constructor code or change the parameter value, we only consider only on that defined set of relative of method calls and the constructor calls during the mutation operation. We compared them with the RT, pure random testing, with the length of this case is 200, and with Suite and with the same genetic algorithm with and without method dependency relation. Time 5 minutes and run 30 tons of different random seeds on each test class. We ran Suite with the default configuration, only except the changing the time for 5 minutes. And we considered different projects in Java that we took from different experiments from search page, either or from different previous experiments on the search page. As we see here, there's an improvement that by using just only implement the NDR or combine the NDR with the genetic algorithm, particularly in such classes like NanoXML, where there is really a couple of many classes that really needs a requirement for the special sequence of calls that to cover particular branches, and also we could almost did the random testing here for line 3. It's because it contains many classes that really has large number of method calls and constructors. Our future work will be proposed approaches. What we've done so far, we focus only exclusively on the branch coverage, and it would be more interesting to see other different coverage, such as data flow coverage or mutation coverage. Also, we think that we can exploit the NDR for improving the initial population of the genetic algorithm, since it's still randomly generated. So we might having some domain information in advance and exploit this information, so we can start produce a better starting point for the search, which may impact the increasing coverage capability. Thank you. We use Suite for the implementation and for the collecting the information for the relation. Yeah. Thank you.
Hi everybody, my name is Akbar. I'm a PhD student from University College Dublin in Ireland, and my presentation is just about preliminary studies that we want nuclear objective feature collection in software product lines, and not decidedly in one in the context of software product lines that are developing. Let's get started. Software product lines, you have heard plenty of presentations this morning about this topic. When I talk about software product lines, I talk about the branch of software engineering that can design the software products based on features that are already existing in the market. So you have a market of many products that are built in with many features. Instead of creating your new own features, you just go and pick up what you need in order to design your product, providing some modifications or setting costs and so on and so forth. And this has the advantage of obviously increasing the usability of your features. Instead of making them once, you allow others to use them, and also to personalize the software because you have many possibilities, so you can allow your software to choose which ones to be used. When it comes to building software architects, when they design new products, then or try to adapt existing ones, they usually have a certain feature that I try to navigate in what's called a feature model. So we have here a feature model, and an example of feature model. This morning we have one related to cars. Here I make an example. I don't know if it's visible for everybody, it's not that clear. I just noticed that. It's about building a mobile phone. So if you would like to build a mobile phone, for sure you would like to have a mobile phone that can call at least. So at least to make this feature to be built in. You might also want to have a screen. You might have also a landline. You might want to make it at least with some visuals. You might want, but not mandatory, to have a GPS that requires some screen, but it doesn't need, it shouldn't have to be basic. It has to be some colors, to have some maps in it, and so on. Obviously, the screen can either be basic, can be with colors, or can be with high resolution if you like to allow your customers to watch videos on it, and also maybe providing some media content. And with this, you might allow them to have a camera and also some MP3 plugins or codecs to read some MP3 music. So this is an example of what a feature model might look like. And once we have this, we might want to select products from them that are valid. So every product that respects the feature model is a valid product that we can consider when we want to create our software. And the usual way of doing it, especially recently, when we try to get these products, is by, first of all, turning our problem into a sub-problem, and that every feature by a Boolean variable, so it's either true if it's selected, it's either false if it's not, turns out into conjunctions of ands of or. So one constraint in the future model can be expressed with 1 or 20. And obviously, you might have a bunch of objectives. As we said earlier in one presentation in the morning, usually there are 5 to use when it comes to software SPSE. And one of them is the correctness. So you might want to have features or products that are valid. The more features, the better for you. After that, there is features used before. So if a feature is used by other companies, you might find them as safe or reliable. And also, if you use them yourself, then it saves you time to adapt them to your system. And also, when you talk about software in the market, some of them are with defects, and you still discover new defects every day, and obviously the cost of your software. When we try to obviously select the features of the software, the product, we are facing some some complex challenges. The first one is these feature models are often large. And in our case study, we use the Linux kernel, which is reported to have about 7,000 features. And unlike what we said in the morning, I agree that there are like about 21,000 constraints in the feature model, but when this turns into a sub-problem, it's about 350,000 constraints, which increases the scale a lot. So yeah, just trying to find a valid product from this feature model is a challenging problem for me. And there is also, as I said earlier, the fact that there are plenty of objectives that might consider that software architects might value, some of them might value reducing the number of known defects because it makes their product reliable. They might also reduce the cost, especially if the company has cash to spend on this. So imagine you have a bunch of solutions, each of them with their respective objective values. So you have solutions A from A to F. We can see directly that the black one are non-dominated ones, so E is dominated by B, so we can discard E and not show it to the decision maker. And we can also put some policies. So let's say we put threshold on the known defect and also on the cost. We don't want solutions beyond these values. Maybe the decision maker might want them, but still we might have some uncertainty. What is the best solution between B and C? And only the decision maker can make this decision. And this is the motivation for why we go into objective music. And as I said earlier, we address this study in particular context, which is the evolving context of software product lines. So as you might know, software requirements and artifacts evolve constantly. As I said earlier, we might discover a new defect in software in some artifacts. Some artifacts may come also, we might discover new ones, some new ones are built, and the cost change also. And also the customers and stakeholders may change their opinions of what should be in their product and how the product should behave. So, and you have seen also this in our study in the Linux kernel. You have noticed through the different evolutions, there is about up to 7% difference from one version to another in a monthly basis, with every few months there is a new version that comes out, and there is up to 7% difference. So yeah, what you have done at the beginning is, first of all, we picked up the Linux kernel, which is one of the largest FM existing open source. And we took the 21 versions existing online, and we tried to study what are the differences between them and what kind of demographics we notice. So first of all, we know that Linux kernel contains about 7,000 features, and as I said earlier, about 340,000 constraints. For the first version, which is the 2.6.28. So when we try to evaluate the demographics, we noticed that in terms of differences between the versions, successive versions, there is on average 4.6 difference in terms of features. Among them, there is 21 that are removed and 78 that are added. So you see, the more we go in the versions, the more constraints and features we have. And same for the size of the clauses we choose. When you take a new constraint, when we look at the constraint in the sub problem, most of them are about 6 features, concerning 6 features, and they are about 39%. So it's not that smooth in terms of the size of the constraints. Most of them are about 6 and 5, and you have few with 18 and 19. But the others are really small amount of constraints. So based on this demographics, we try to generate our own data set in order to have more data sets to test on and to try and to evaluate and have broad analysis. So yeah, we took the same demographics. We try to generate new instances with 2 variables, 2 parameters. The first one being how many features are modified, and the second one being how many constraints also are modified. So the higher these values, the more evolved is the instance from the earlier. So as I said earlier, we take the same proportions as what you have seen in the previous slide. So these are the values. We use modified constraints from 5, we go from 5 to 20%, and number of modified constraints from 1 to 10%. And we generate 10 for each of the combination of the 2 parameters. So yeah, and we have a look at the literature, what is the state of the art when it comes to multi-objective feature selection in software product lines. And the latest work was in ICSI 2015 and proposed by Hinard. And it is based on an IGA, indicator-based genetic algorithm that is coupled with a SAS solver. So what they were doing was just at the beginning try a random selection of populations, do an indicator-based genetic algorithm on it, and every time there is a mutation, they assume using a SAS solver in order to make the solution feasible during the mutation. So yeah, this is called SAT-ABA, and the algorithm was run on several instances and several metrics. But SAT-ABA, as I said earlier, does not consider the evolving concept of SPAE. They just consider that they have one feature model and they try to optimize it. So what we have done ourselves is that we took the same solver with the same parameters and said, if there is any evolution, then we'd rather take advantage of the previous optimization, or what we know from the previous version, and try to inject it into the SAT-ABA solver or optimizer with the same parameters and see what is going to happen. And this is what we have done. It's almost like sealing, but we take the same generation, trying to modify it in order to fit into the new problem and see how it behaves. So sealing is not novel in its own, but the fact of taking the entire population from the previous one and trying to adapt it to the new one is some kind of new concept. So in terms of quality indicator, we use the hypervolume. What they argue in the paper of Hinard is that it makes the best improvement in terms of hypervolume, while we keep hypervolume, but obviously there are other metrics that we should look at later on. So if you consider here the same example in 2 objectives, you have in black the best solutions, and you have a reference point which is far away in the space. Then the hypervolume, or here the area, is just the area that is dominated by the mobility. And the more you increase the dimensionality, here you have 5 objectives, and it becomes a hypervolume. So yeah, this is the kind of result you get. This is an example with 10 features modified and 3% modified constraints for the first example on the left-hand side, and 10% modified features and 5% modified constraints. In red, you have SAT-ABA, and in blue, SAT-ABA. In terms of hypervolume, when you run the algorithms for 20 minutes. So 20 minutes is the baseline that they use in the paper of SSBSE, so we try to keep the same conditions. And what we see here is that both algorithms covered, which is a good thing, at least in terms of hypervolume. We notice that in blue, our solution starts with a better hypervolume because, as I said earlier, we try to take advantage of the previous results. And actually, the best thing is that we converge 10 times faster. So if you notice here, almost at the first iteration, we reach the same result as SBSE when it reaches the final result. And the good thing, at least for these instances, is that we are converging to the same result. It means we are not switching the results towards one direction and stuck it in some local minimum. Yeah, and as I said earlier, during the first iteration, which is about 100 seconds, we are reaching about more than 100% improvement against SBSE, which is, I think, a good improvement. And when, as I said earlier, when you look at these numbers, which is the number of features modified to the percentage, and here is 5%, here is 20% and 10%, we notice that for larger modifications, we are starting well, but we are converging to a value that is a bit slower, a bit lower than SBSE. This is because we are taking the same parameters as SBSE, which means SBSE with parameters optimized with lower mutation. We are tweaking, we are really shifting our optimization towards only the knowledge that is wrong, whereas SBSE starts with a random population, which gives it more freedom in order to explore more things. So this is where we should have some extra work in order to compensate, either try to change the parameters of SBSE on the fly when we notice that the change is larger than the original version, or maybe add some extra corrections or installations. So as I said, this is the conclusion. So what we have done in this work is we try to introduce a new problem for configuration of software product lines when the FM CLR based on concept evolution. And we have proposed a benchmark for this problem that is available online. It's on the proceedings, the link proceedings. And also proposed SBSE, the fact advantage that adapts the previous state of the art and takes advantage of the evolution of the software product line. And what we notice is that SBSE outperforms SBSE. In particular, it converges 10 times faster, which is a decent result, and achieves an improvement of about 113% in the calculation of the calculation of 100 instead of 20 minutes in order to the same result. That's all from my side. Thank you very much. Any questions? We didn't take, at least in the first, we didn't take anything in SBSE. We just the solutions that we are studying, we modify them before injecting the details. But SBSE, we kept it the way it is with the proper parameters. And that's why we noticed that the more constraints and features that are modified, the farther we are from the original model, the lower the rate of our results, because we don't take anything in SBSE. But yeah, changing SBSE would be the next thing to do, everything. And actually, if you notice that we are reaching good results in one generation, maybe even notified something is worth to do. Because what's the point of running many iterations if you are reaching good results and you may be using the local service or something like that? Yeah, definitely. The first thing would be, first of all, to have other methods to be fair with the comparison with SBSE, because SBSE they argue that they are better in hacking volume in the fact that they say that they are SBSE. So that's why we use the hacking volume. But for sure, to be fair, we need to compare with other methods. That's the first step. The second step would be maybe even injecting SBSE and see something that would be something. I don't know yet, but I doubt it's going to be this. Actually, the way it works like this is because we don't need to collect disclosure that much. Because the way the policy is defined, one of the objectives is the amount of constraints violated. At the end, we try to filter them. I don't know if you know, but usually it's actually this morning, but about 1% of the products are valid manually. So if you don't add the number of features of constraints that are violated in the objective, you evaluate any initial population. So we take this as an objective rather than a constraint, like satisfying all the constraints. So if you would like to do it in any other field, you need to have a correction that gives us solution that easily to the next model. You know what I'm clear on? But if you have the initial version, before injecting the solutions, we need to make sure that they are valid and relative to the second one. And that would be the bit why we cannot, at least the way it is, we don't apply any other security, except this problem where we accept, for now, solutions that are not valid. Enter the lens data. Any questions?
Yes, you turn on.
That was better? Okay. Yeah, today I want to share with you a small idea that I started with, which is trying to integrate the interactivity within the post-med detection. Because post-med detection is one of the really considerable art that people have a lot of software engineering, and I'm trying to revisit detection and trying to optimize it. So today I'll talk a little bit about post-med detection in general. That's what it is out of it. Then I'll show you how you're taking and trying to optimize. Then I'll introduce to you the interactive post-med detection. And I'll show you some initial results, and then I'll conclude with some future predictions. So we all know that automation takes up to 60% of the software. Developers work 76% of developers work on maintenance-related tasks. They spend 60% of their time trying to understand the code, and with all this effort, they are still experiencing software failures that go up to 2 million times in 2015. So it's clearly that understanding the software is a problem, and defects are known to be the reason why this is the case. And as an example for defects, of a famous example of the blood loss is one of the most popular and well-mined defects, and it can be seen as a controller class which is abnormally large, with not necessarily children or parents. So if you look at this class diagram, it's obvious that the controller class is the class which can be seen as a blood class. And the way we actually can make this conclusion is to looking at the definition and coming up with an application. So you look at the controller maybe as being of class with high toughness, and also it's extremely large. So when you look at the lines of code on 2 points, if it has no parents and children, then there's no, you can look at the depth of this class. So you'll be able to come up with an interpretation and you can scan this and say, based on these properties that I see in this graph, the diagram here, I can measure and decide that this is the detection. And this process is going to be the smell detection. So the smell detection has been well known in the area of software engineering. It dates to the mid-90s. Several points and goes in several layers. Has been mining those smells into several layers, starting from the web services to the models, to the packages, to the source code. Now we start seeing even into early 2000s with test smells. And coming up with new research. Here we have several smells as well are very popular in detection in these areas. And start to show where I'm trying to contrast my work against what exists. We have to look at researchers have been detecting the rule-based techniques which look at the definition of the thought smell and try to come up with interpretation in terms of thought. Like for the example that we have previously seen. Techniques which try to visualize the source code and allow the developers to point out and analyze the source code, but also it might be a little bit hard when the system is bad. And approaches is try to use other sets of manually defined or well-known that then they use it as training set in order to manually classify it. Of course, with that being said, if you have a large system, then manual validation is a human-intensive task. It's not that efficient. Techniques which try to use co-evolutionary computation and use to define complex personality effect and try to find a suitable set of detection rules to detect them. And this shows that all these approaches they overlap in detecting several blood smells. With that being said, as a developer, you would have plenty of choices to look at. And with a different example, I will take three very known and well popular detectors. The definitions of these detectors for the case of blood class is the following, and then you can translate this definition into the detection rule. The detection rule is the composition of metrics and thresholds. If you take a new input system and you try to apply detection rules, you'll end up having each one of them will have a set of detected classes as classes, and you would notice that there is an overlap between them. So as a developer, you may not be able to distinguish which of these tools is the most accurate tool. A lot of studies are trying to link the accuracy of these detectors based on the body code, based on the code changes. They will try to look at that as means of being a good detection. But again, knowing that we have several code smart detectors and keeping in mind that they overlap, and if we consider all the metrics that they use, this will leave you with a pile of possible metrics to use if you're trying to build your own detection rule. Especially is that a lot of these tools, they allow you to personalize your tools, but it's not an easy task for developers. And the reason why this is not easy is that because there is no consensus between the definition of a blood smell and how it is being defined as a rule. Asking developers to tune manually the detection rules, coming up with the thresholds is hard. Also, considering all these metrics, as you can see, they're all structural metrics. So what about the semantics? Can we use that also to detect those tools? And also, what about the developer's intuition? Because developers, they may not know about the detection rules, but they can see the insights of the code, and they may have their own perception of what is bad in the code and what is good. So how can we interpret that in terms of metrics? So all these questions remain really hard to answer because of the process that we take, and the common point between all these techniques is that they take a definition, they come up with a detection rule, then they come up with effective code elements that they provide to the developer. So I thought of why don't we do this the other way around? Why don't we add one more cycle in which we allow the developer to give a feedback about the detection entities, and we feed that feedback to detection rules in order to be able to probably create user-customized detection rules. And to do that, I introduced the interactivity into the customer detection, and this can work again by taking, for instance, 3 popular detectors. You can take more if you want, but for this study, I only considered 3 for now, or 4, I guess, 4 for now. So I run these detectors, and I come up with a list of, for each one of them, I'll come up with a list of candidate classes that are infected with the phenomenon of blood clots, for instance. And then I will rank these detectors based on the degree of overlap. So a detector has a high number of overlapping classes with others. Maybe this can be a sign of confidence that this is probably a blood class. Once I do that, I will feed the results of that specific detector to the developer. The developer will decide if this class is actually a good class or not. So we'll give a binary decision about these classes. So once we do that, we take these feedback in terms of accepted smells and rejected smells. We introduce them to the genetic programming in order to pull the search space based on the accepted good smells and rejected good smells. And by doing so, we will able to define or refine the rules in order to probably detect more of a user-defined good smells. So this is the idea that I came with, trying to see if this actually could work. So to look at what this can help, I started with a small tests which I did a cross validation with three detectors. So the one, or this is probably one way to look at this. So I decided to do the cross validation, which means I take each detector as an ideal set, and then I would take the results of this detector as an ideal set, and then I run the other three detectors to come up with the precision compared to this one. And then I keep doing it for each one of them, and I consider them as, and I take the mean between them to come up with the precision and recall. So I consider for open source systems that are known to have well-defined, flows, unknown to personnel. And also I wanted to notice the huge overlap between the detectors that I have, that I have experienced in this experiment. And as you can see here, that the number of precision and recall is pretty high for all of them. This is because of the high overlap between them. And the purpose of this is to see if I allow my interactive detector to take feedback in terms of how far I am from the idealistic set, how can I be able to pull the search space and get closer? You will notice that in terms of precision, I wasn't really able to, do better than existing detectors. But in terms of recall, I was able to slightly push, give a small push to the detector, to the in-text converter detection. So it's again a promising results because I was able to allow the developer to give with this method, you can allow the developer to give a black box feedback, means allowing the developer to look at the source code that they master and give you feedback instead of asking them to tune the detection rules. And also with a small feedback that can go to up to 15, 20, on this experiment, 15, 20, and 15, with the accepted guess, rejected the personnel that I was reporting to my genetic algorithm. And this will allow, with that small feedback, this allow me to be able to push the recall. So compared to machine learning techniques that will ask more than that in order to be able to sample the specifier. And also for this is the promising results, and I still try to look at several other directions. One of them is, for now, I'm just tuning or fine-tuning the metrics that are given by the best detector. What if I allow my algorithm to take into account several other metrics from the pile of metrics that I have really seen so far? Maybe this will allow me to probably get the better results. Also, what if I can use this idea to come up with a compromise between different decisions? If I take every detector as a decision maker, would I be able to come up with a compromise between them? And also, what if I allow this metric or this idea to allow me to be able to cross disciplines between several layers? Because a lot of studies right now try to link and detect personnel that can be correlated between several layers, such as the personnel layer or architectural layer, etc. Thank you very much. prevent them or repair. First of all, they are unpreventable because based on a paper, 2015 XC paper, they shown that even most experienced and senior developers, they can still introduce bad decisions in the code because they have to meet deadlines, they have a budget. So it's something that we cannot really escape from. So preventing it would be, of course, the most idealistic, perfect thing. But if they are there, and we know that they are there, then also it's better to probably fix them. But again, this is a detection technique, fixing them is even harder.
In that case, it's better to predict when the logic fails rather than predicts. So if you tell them which is wrong, how can they
That's actually a very good question because I was discussing with my roommates about the possibility of defining a percentage for the code smell. If I see that I'm adding into too many features into one class, maybe I can foresee that this class will become a good class. And maybe as a preventive action, I can prevent or ask developers to be aware of such milestone. Yes, it's a very good, it can be really a very good contribution in the future. Yes. Mm-hmm.
Yes. Yeah, I have a question about the main goal of, in general, the interactive detection of smells in general. It's first of all in terms of prioritization. So because if you show to the maybe designer or the programmer maybe a large list of code smells, maybe that's really very time consuming to go through different code smells. And so I believe one of the main goals of the interaction is to learn maybe what are the main preferences of programmers, so they can maybe catch quickly like what's the code smell that they want to fix rather than looking through huge list of friends. So I don't know if you're in your interaction mechanism, are you considering trying to reduce the list of code smells that maybe the programmer they are looking for, because that would be a time-consuming task to like look at so many code smells and give his feedback about it. So it's better maybe to reduce that list. Is there any mechanism that you are planning to introduce in order to reduce that list?
More than I know of, maybe if I have multiple interactions with the developer, I can learn from those interactions. I don't know if I can do that in the first interaction. Maybe there's something I can do, but I would think that I may have several interactions and maybe I can start seeing a pattern in the kind of the code smell developers will be interested in fixing. And maybe I can use it to prioritize that and save time.
Okay, and my second question is that there's very recent empirical study that will show that they started to study the correlation between code smells and refactoring opportunities. And they found that actually what happened in practice that most of the refactoring opportunities didn't correspond to code smells. And I believe that could be motivation for maybe interactive refactoring opportunities detection, that to learn what are the refactoring opportunities that in practice programmer they are looking for. Because if you just take out the hypothesis that most of the refactoring opportunities are related to code smells, and we found that in very recent empirical study that it's not the case in practice. So maybe suggesting something which is around interactive refactoring for learning what are the opportunities that I'm looking for. So in your experience, I don't know. I know it's just an initial study, but did you find that I don't know some of the programs they mentioned that I'm not interested at all to any of this code smell. I have some other priorities in order to fix some of this quality issue that are not really code smells, but could be some others.
Yeah, referring to that study, I think that we have several tools that are trying to detect refactorings between different releases. Maybe to look at when a developer they act on or refactor a specific class, and then if you are able to extract all the refactoring that were done, and then look at the evolution of code smells within that project and this class, we can see if there is a correlation between the refactoring and the code smells or not. If it's not the case, then definitely, of course, we can always learn about that. Yeah.
Mm-hmm.
Yeah, that's a very good question. Actually, it does not hurt much because all of the classes that are given to the developer are actual gut classes, either detected by that, by the most, like the most ranked detector or the others. So they are all candidates. So if the developer would do random choices, if that's what you said about the choice of the accepted and rejected, that wouldn't really hurt. But I think that would hurt if I allow multiple metrics to be added and I allow the developer also to choose outside of that list. Then of course, maybe that would definitely hurt if actually. Mhm. I think this can be seen also as preferences research skills. Some people would be interested in looking at the opinion of the decision maker and try to see how the opinion is affected in the first place. And then we can see if we can build maybe a hyperplane of reference points and see if we can find anything within that hyperplane to see if those solutions within that hyperplane maybe they will best have a compromise between all.
Maybe a question related to the previous question. So maybe you are now trying to include the developer in the loop after a number of iterations, try to ask the developer to give his feedback, and based on his feedback, we try to convert to a specific direction, right?
Mm-hmm.
So yeah, maybe if the developer is not familiar with the code fragments or with these many classes, so maybe this feedback could not be useful. So maybe one of the criteria that could be considered the expertise that the developer with these code fragments. That will, of course, will affect the influence on the final results.
Yeah, as I said, if those code smells that the developer is seeing are necessarily code smells detected by at least one detector, then that wouldn't hurt too much. Unless I allow the developer to give me and say and mention that this class, which I have not detected as a code smell, is a code smell, then maybe this is going to deteriorate, of course, the equation. And of course, if you have a non-expert in the loop, then you'll get his non-expertise into your algorithm. So yes, of course, if you have someone who's expert, maybe definitely you'll be able to have better results. If you have any idea how to do that.
Yeah, maybe so you have the list of developers and you can see over the history of comments or trying to release most frequently changing these classes so that you can improve it. But another issue maybe, so you know that detection of cosmetics is subjective task. So maybe if you have two expert developers, so maybe they disagree about the candidate cosmetics. So do you have any mechanism?
That's one of the things that I'm trying to do, because if you consider each one of them, because each one of them would have an opinion. If I take I would run this interaction separately for each one of them, and I come up with their rules, and then I feed their rules as separate detectors, and I see if I can find something between them. Maybe this is just an idea, but I'm trying to find the compromise there. Professor Mendes said some good idea.
Okay.
Mhm.
First, I just want to confirm whether this developer come from university or.
As for now, I have not used any real human interaction, because when I used the cross validation, I was comparing against the ideal set. So, but I am more happy to, of course, to try this with subjects.
I come from Huawei, China. Actually, from my viewpoint, I think there's no any opportunity for a developer to use different code smell detector. From us, we can only give them only one detector. They just use it and remove any smell if needed.
Mm-hmm.
So I think they can
But if I want to, because every developer is expert in the source code, and the developer wants to put his expertise or her expertise into the detection level, means if they want, and we all, since you're familiar with these systems, we all have classes that we don't want to touch. Suppose that class is an actual bad class, but for some other reason, you don't want to change that class. You want to exclude that class from your detection.
For tools improvement, I agree this is valuable. But if you make it as a routine activity, then it becomes a big problem because in company there is a politics because people will care about their performance. If we report code snail, then as per company policy or process policy, they should improve their quality of product. So they should do. So if you give them this opportunity, they will always say, no, 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 this is not code smell.
I see. I can, of course, yeah, you're right. I mean, unless they, but they are, by the ethics, they are supposed to fix their codes. And maybe if they are able to have their own detection rules, they would, because the problem was that I would see this as if the developer is not able to know where they have or she or he needs to fix the code, or because if they are able to catch that implicitly without anyone knowing about it, they would fix it. I would see if this is a good opportunity for them to see if a developer knows that they have bad patterns in code, and if they can train a rule to detect this pattern, maybe they can do that without anyone knowing, and they can fix the code. If you see what I'm saying.
One would help. Doesn't matter.
我也骗药粉。我他妈也想自己干。他们就说，因为下午但是那个中国人好屌，对，是他妈是中国特色。一问这个就能憋到。确实，我还问那个东西确实是他妈。确实，我听着我都还没想到这点，但是完了一个，是有点傻逼。客户的肯定要信，能不能确定？给我买了吗？那个啊，可以转给你，这个备一下。10月11号到，10月11号，今儿19号，后天4天到，周一。周一。
Now that you say this, I do remember getting a comment section.
你直接打我把那个邮箱发给你，
行，
打那个邮箱。
行，我主要想要个架子。
为啥？
就是你不觉得那个啥的时候看的时候老这样就我特别的横吗？哦，就这儿这个地方。
可以把你那个接到那个显示器。
没显示器啊，家里。
哦，是不是给家里买？我以为你给实验室买。
哎，实验室我都不用我电脑，
你直接用那个。
是啊，
把资料什么丢了，最好还是
都在我的云端呢，资料。
那就行。
对，我全部都在我那个优米使邮箱，那个优米使邮箱被黑了，那我简直了。
放平了。啥时候开始第二个？
过半小时吧，不出去走走吗？你。
Make it very abstract. So I guess
Well, yeah.
互联网到微店，到。
Yes. So, and she talks a lot about so a few years ago I supervised an ACS. Yeah, it's a major process, and then we ended up never actually, even with people like Mike switching we never go to that level where we actually really do experiment with the system. So, but your idea that you suggested is work on the quality I don't think that's just at the university of Maryland. He doesn't really do a lot of work in research engineering. Every day, and one of his graduated PhD students now works at Google. So then it works, right? Because then your student can say, we should have like this person for 7 months. And he was at Google for 7 months, actually working directly with the testing engineer.
attempt to the company, you know, at least that they work also help and the trouble with that is that sometimes I guess in company structure
Yeah, so I had exactly that happen. I had a colleague who used to live in Texas. He used to live in India, and his company was bought out by a company on there. We had those arrangements already in place. He didn't want to have his company got bought out, it's something maybe I had a little much personal feeling.
But I understand, I totally understand.
That's really challenging to add into the yeah. So to be honest, I have no idea how you do it. How do you control them? Yeah, I'm really impressed, but it's, I mean, that might be more than I would be able to manage. So do you want to take on any new projects or? Yeah, sometimes feel like I keep saying myself, I can't believe you're still not done with that. And you have to go to those uploads. Yes, yeah, so we still have 2 investigators. And one of them is embarrassing in that station. Last summer. And every once in a while that happens. They don't give you a hard time sometimes. So you were not recording people. Okay.
It's like essentially a week of work. So you might.
So that's really.
So see, that's my sort of.
Well, it's still really impressive. Yeah, I'm always teaching most of the time. I teach 2 full classes per semester. And I suspect your enrollments are similar to all my
Yes. And that's why I'm
yes. So then we say you already plan to stay at UCL.
So that's why I added 2 years.
Okay.
Then for my mistakes, hopefully, we will use everything. Please try to find mistakes.
I've only visited the group. Yeah, I always really, I think the first time I visited was that was a long time. The part I thought it was so good. Yeah, the first one was really good. But also really obvious. You know, here I'm visiting and he's like insisting on taking me throughout and I have a very severe here he is like talking about It was just, in that regard, it's really impressive how willing he is to go out. So,
That's very good.
yeah, I agree. So does Nicholas still regularly do any work in search-based software engineering? Okay, but he is still somewhat connected to in SSBSE, is that right? Yeah, he is. Right. Yes. Oh, okay. So if he's got all this in your business, because when I told him, this was years ago, he was saying, I'm going to start transitioning things that relate to music, computer generated music. So I've looked at some of those papers, but they're just so outside my area. I think you get something about static analysis or slicing of music, so but that was the only time I saw it. Yes. And I assume he's still teaching classes. Yes. Yeah, I can remember one. Yeah, I'm very. I actually know someone who's at the University of Colorado. So what was your what? Yeah. So what was your? Oh, okay. So what was your experience? Here.
Not six, but one of the six, but one of those that they actually.
By the way, Phil wrote to me after the talk and he said, so I guess this is not a good moment to come to the United States. Because one time he was coming to visit me and it was really heavy rain and he had a flight to go to one city and they got canceled. And they had a flight to go to another city. And I said, don't go to that one. There's no way you'll ever get out of it. And then there was another city where it was like 6 hours driving distance. So I just on ended up driving to like Detroit, Michigan or something like that. I had to get back to my school. So he wrote me a note saying, based on your experiences in the hurricane, I don't think I'll ever come to the United States again. On the eastern half of October or November, please come to the UK instead. So, well, it was really fun, but I hope I didn't take enough time. But again, we had portions of that project that was related to the really neat.
Yes.
Yeah. I mean, that's really exciting. So do those types of awards and that would make it easier for you to get that Right, so everyone already has a strong CV. So if you have that visibility. So do these tools matter when you're applying for those? Or is that Yeah, it's actually. Sometimes it's hard to say. I'm sure. That's what it means. But as one of the I mean, the question was. Oh, yeah, so like, so, you know, 6%.
Yes.
Oh, so this, okay. So what about the?
Yeah.
So you get to.
Well, depends on your.
Yeah, so then I just, so. But I suppose some of the tricking is with
Yes, yeah.
similar to the fellowship.
But that's New Year, so you know what.
Everyone's
And
it's the.
also.
Oh, I see. So can you submit more than one time if you don't get it the first time? You have multiple tries? Yeah. Well, I hope everything goes well. So was it January 2017?
No, I just. So.
She has a list that she has to fill. You use a lot of your time on Google Hangouts or Skype. Sure. Yeah, great.
See, what you, the thing you want to find is not types, it's constant. Things with amount, size, but something structurally.
No,
So
so
my immediate reaction was cognitive.
yeah, so okay, that's a good question. So right now, all the Phil and I have added into the tool are things that are for strings, characters, you know, numerical values with decimals and integers. But I think that there would be a way to do permutations and combinations. I've had bad solutions to that in genetic algorithms before. And I can't remember which journal it is. There is a journal that has a paper about using GAs for permutation problems. And I want to say it was couched in the context of like solving a TSP or something like that.
So that's but APMs are supposed to be making a whole
Right.
I cannot see the space of
Like how do you make a small tweak and then how do you accelerate?
what is acceleration?
Yeah, so how do you take a big jump, I guess? So then I guess we'd have to have some kind of understanding of what big jump means for a permutation. I guess I understand what a tweak would be, but you're right, I'm not sure I know what a big jump is.
So far, that's maybe like people with it accelerate the function of the exploration is either earlier or later, and then accelerate. But that will result in many questions. And then eventually go down to.
Okay, no, I see what you're saying. Yeah, I don't have a better solution at the moment. Phil and I will talk about it.
So far, things have been tried.
Yeah, so primarily we're dealing with data types that have an amount. We're a scalar value. But that's certainly something we'd like to, I mean, one of our goals is to try to demonstrate the generality and simplicity of the framework. So the more examples that we can have collaborators add in, our hope is that people will be willing to do things like, you know, clone the repository or fork the repository and then submit a pull request for adding in new features. And Phil's idea is that maybe this is the sweet spot because we have some other systems, like Phil and I are doing some work on testing mobile-ready websites, and we've tried to put that tool on GitHub, but we feel as though maybe sometimes it's too big, it's too customized, it's too complex. So now we're trying the opposite end of the spectrum and thinking about a smaller, simpler, easier to access and use tool with the hopes that maybe we might get more people forking the repository and submitting pull requests and things like that. And by the way, I do have to say again, it's nice to see you. I know we haven't been able to talk to each other for a number of years now. I'm doing well. I'm doing well. I'm still at the same academic institution. I'm working on projects with a couple different people. Actually, I'm jointly supervising 3 students with Phil who are at the University of Sheffield and working on a couple joint projects, one with a colleague of mine in Taiwan, one with a colleague of mine at the University of Colorado Springs, and then a few other smaller projects, but still broadly in the area of software engineering and software testing and analysis. Phil and I are really excited about the project that's related to mobile web testing. We just submitted a paper to ICST, and one of the things that we've really been enthusiastic about is that the technique we've developed is actually finding responsive layout faults on production websites. So like we're finding mistakes on Duolingo.com or StumbleUpon.com. And of course, we surmise that those have gone through extensive testing, and we're still able to note situations where, you know, at a small number of viewport resolutions, there's still a bug in the layout that people have overlooked. And in some of the cases, Shin, it negatively influences your ability to use the site. Like there's a key feature you can't use. And if you are on a device that is at that resolution, you can only change the resolution to this or this, and then you're actually blocked out of that feature. So we think there could be a lot of high impact work that comes out of it. We had one short ASE paper, and then we're hoping to have another journal paper submitted very soon. And then we have that one paper in ICST as well. How about for you? Okay.
But
Right. Yeah, I'm familiar with the challenge as well. So, I wanted to ask you, is Shawkat the lead here? Okay, he's from Simula. I'm sure you would know him. And I wanted to talk with him because he's done a lot of work using AVM. And we'd like to be able to actually take some of his ideas and directly integrate them. But I never saw him in any of the sessions, so I was guessing that he's probably not here. Okay, well, good to talk with you.
Okay, hello everyone, and welcome back to the last session today. My name is Ali Omi, and I'm chairing the last session, which is the graduate student session. So I guess this is the most important session because our students are waiting for your feedback. this is important to get some comments and some feedback from the SSBSE engineering community so that they can progress in their work. So the work presented in this session is not expected to be complete or to have full validation. So the main idea is that they come here and present their work and get feedback from the community. Okay, so we have 4 amazing presentations. The first one will be by Jocelyn here, and it's about dimensionality reduction for students software factoring. So we just changed the order because Jocelyn will leave later. Okay, please. Thank you. So. Thank you for giving the presentation. My name is Justin Dia. I'm a PhD student at the University of Michigan, Global. And this is part of my PhD work. And I initially started doing my research doing interactive software refactoring. And during the first work I did, I realized that interactivity can be very tedious, especially if the evaluation of a software factoring require a lot of parameters, especially metrics, value to make a decision. So at the beginning, when I did the evaluation myself, I would start really enthusiastic, and then after a few minutes, I get tired, and the evaluation is not funny anymore. So I start to think about, is there a possibility to reduce the number of objectives so that I don't have to give the domain expert that is evaluating the refactoring a lot of matrix value that might be even conflicting for him to make a decision. So I came up with this work in which I would like to study if it's possible to improve the performance of the many objective software refactoring using dimensionality reduction. So in the work, I will talk first about the context of the work as software refactoring. Then I will give an overview of the method and give some preliminary results after that. So, as Mohamed said earlier, there are always changes in software, and every time there is a change, we want to understand what has been already done before we affect the existing software with changes. And it is known that almost 60% of the time spent during the change is done trying to understand the code. So this makes software refactoring a very important activity because it will allow us to improve the structure of the software so that anyone who would like to read it and do some change can understand quickly. So refactoring seeks to improve the code by changing the internal structure without changing the external behavior. And there are 2 main steps. The first one is to detect the code fragment that need to be changed. And then the second step is to identify refactoring operation to correct the defect. So in my work, I'm assuming that the smells have already been detected, and I'm focusing on the refactoring part. So Mohamed already gave this example a couple of minutes ago, so
I will go quickly. We have an example of a block or block class, like you said. And then we use the factoring to break this class into different modules that are either functionality oriented or encapsulate the number of operations that make sense, like a unit. So we have a main library class, we obtain catalog class, book class, and some other new classes are similar and also concerned with the same type of objective. So the existing work, we have metric-based approaches, especially research-based techniques that are of interest to us. And we have the graph-based approaches where we use graph transformation to make the factoring decision and representing the software in terms of graph. So my work, I'm continuing on what some of my colleagues have done in the lab before. So the many objective refactoring by using existing genetic algorithms and applying them to software factoring patterns. So even though there are already significant work on many objective refactoring, we still have some challenges that need to be addressed. And one of them is the convergence of the optimization algorithm. So it is known that for the convergence to be really effective, to be quicker, we need to have non-conflicting objectives. And also, as you can see in this graph, in this example, when the number of objectives is increasing, you will see that the algorithm used here, which is the energy tool, has difficulty identifying, distinguishing the solution to be taken into account for the next iteration. Another challenge is the visualization or decision making. So after you have done the refactoring, usually at the end of the refactoring, you want to show something to the developer so that he can make a decision whether the refactoring is actually something parameter to show to the developer, then it will be very difficult to represent them for him to make a decision. So based on all these challenges, we would like to bring a dimensionality reduction approach that will reduce the number of objectives we represent so that the decision maker can have a quick view of what the refactoring is building as component in the system. So our research is based on a question that we need to answer. So for us to reduce dimensionality, we need to know first that our problem is suitable for dimensionality reduction. That is, objectives that are dependent, among them. So if we don't have objectives that are dependent, then we won't be able to reduce the dimensionality. The other motivation we have is to find effective objectives. So let's assume, for example, that I'm even using a lower dimension to start my algorithm with. Let's say I start with two objectives or two metrics. Which metric should I consider to run my my algorithm? So we don't know. So usually we have more than two metrics. So if we can go through all the metrics and retain which one are really important and contain more information for our system, then we will achieve actually a better analysis. So doing dimensionality reduction, we will start with a lot of metrics, a lot of fitness function, and then during the analysis, the algorithm will itself decide on which metric to return at the end of the analysis. So our approach is based on the work of Dr. Baird, and it's a combination. We are starting our analysis with a combination of principal component analysis and NSDA2. So normally the main look of NSDA2 is in group. So we start with a random population, we do all the change operation, and then we go through a selection process. And if at the end of the selection process we evaluate, we can decide if we should stop or continue with the analysis. So now what we are introducing here is after the analysis, we want to, if we continue, we would like to know if we can do a reduction of objective by using the PCA block. So what we have implemented right now is we will decide to run, for example, the genetic algorithm for a number of generations, and after the solution has been stabilized, that is, the best solution is not changing anymore, then we run PCA to reduce the number of objectives, and then decide if we continue with another round of genetic algorithm with a lower dimension. So, for an overview of the NRGS2, it's the non-dominated sorting genetic algorithm. We start with the current population, and then using the current population, we generate offspring using genetic operator like crossover mutation. And then we perform the sorting to generate different fronts. And the front, we can have the best front, and then if the best front is not enough to meet our population size, we generate the next front, and so on, just until we reach the size of the population. So after we have the front, we do sorting in each front, and then we have the next population. So for our PCA stage, we consider the solution of each solution in the population of genetic algorithm as a sample. So this sample, we represent them in terms of variable, which is the refactoring sequence, and then the objective sequence of the objective, which represent the different metrics that we use to evaluate this refactoring sequence. So we use the objectives to build up the data matrix, which is the F matrix, containing each vector of objective. And then from this data set, we generate the correlation matrix as described in the formula for the VIG, the covariance, and then from that covariance, we calculate the sample correlation matrix. So the PCA step, so we run first the NRGA at the start, we run the NRGA at the IF iteration, we run the NRGA G time for G generation, and then at the end of the NRGA, we will build the matrix of data from the different solutions in the population, and then we will run the PCA on the correlation matrix of objective. And after the PCA consists in performing eigen decomposition of the correlation matrix, and then from that eigen decomposition, we will select a certain number of eigenvectors that represent the principal component. And this eigenvector will analyze the different objectives in the eigenvector to select the conflicting objective. And if after that we do the evaluation and the stopping criteria is not met, then we will restart again. For selecting conflicting objective, we go first with the first principal component. The first principal component corresponds to the
principal component with the largest eigenvalue. So the way we choose is to choose first the first two objectives that have high magnitude principal component. And if we have also problem finding the two objectives, then we will resort to correlation analysis to see which are the objectives that have the most negative correlation between them. And then for subsequent a principal component, we choose the next objective with the largest value. So for our preliminary results, we wanted to answer first whether our refactoring problem is suitable for dimensionality reduction. So for that, we took an open system, then project, and then we selected the 7 software metrics as objective to evaluate the refactoring solution. And these metrics are the coupling, cohesion, complexity, and so on. We use a population size of 20 and 50 generation, and we are only interested in the first PCA. That is, after we run the genetic algorithm for a number of times, the first PCA that we perform, we want to analyze the eigenvalue and eigenvector for that PCA. So this is the distribution of the analysis. So here we have. I separated the image, the plot in two, so that you can see all the eigenvalues, because the scaling is some are really small. So on the right, you have the most dominating eigenvalues, and you can see that almost all the energy for all the variation of this data set is in the first eigenvalue, which has a scale. The normalized value close to 1. The median value is about 9. So this tells us that even though we started with 7 objectives, almost one dimension can be considered to continue the evaluation. So we don't have to continue with all these objectives. I also look at the count of eigenvalue given a threshold. So if I want to, for example, I say, okay, I will select only all the principal components for which the sum of eigenvalues is equal to 99%, for example, of the variation of the data set, or 97%. So doing this analysis, we found that for us to keep 99% of our data set, we need a median value of 2.5 objective. 2.5 objective. And if we want 97%, it will be 1.5 in median. So if we consider all these results, it appears that even though we started with 7 objectives, in maximum, we can continue with 4 objectives, which is the maximum value for the 99%. And even that 4 objective is much far above the median value for the eigenvalue. So from this analysis, we can conclude that dimensionality reduction is possible for the refactoring problem. And with this example of 7 objectives, we can reduce, for the first PCA, we can reduce the number of objectives to 4. So in future work, we'll be investigating the problem further by trying to compare our approach to the energy algorithm and also to other methods that exist already in many objective refactoring problems. So in conclusion, our goal is to find a refactoring solution in which the number of metrics used to evaluate the refactoring is less so that we can also not only improve the time and the performance of the algorithm, but also we can use the result of the analysis to guide decision making and also improve visualization. And using our PCA approach, you see that we can achieve that goal. And in next study, we will see how effective that goal is in doing the actual refactoring.
The original objective started with, or they said,
The original objective I start are not transformed. So normally in normal PCA, when you do objective reduction, you go from the initial space, and then after depth dimension reduction, you will actually obtain a transform space where the dimensions are usually orthogonal. But in our case, we will not continue in the transform state. We want to actually continue with the initial state, but by dropping some of the objectives. So once we find the principal component, we will look at the objective in that contribute to that principal component.
additionally, see the principal component in the effective direction of the combination.
Yes. Yes. Yeah, the principal component is a combination of the initial objective. But still we can see, for example, if I take, for example, a principal component, which objective really contribute to that direction. Right? So if I can determine, for example, the objective that contribute mainly to that direction, then I will keep those objectives and drop the rest of the. I've not tried anything in the transfer space, but I also think, like you are thinking, I think it will be worthwhile to actually redefine also new objective based on the transform space. But this will be another study. Another question?
What is your exact plan to evaluate this approach? So far, you explained to us how to use a number of objectives you have and the problem. You mentioned that you can reduce for objectives, but it's still remaining yeah. I'm wondering after that, what is your plan? How to evaluate how to convince us that this is
So first, the reduction that I showed is only for the first PCA, for the first dimensionality reduction. So after the first dimensionality reduction, we will run again the genetic algorithm on the new set of objectives. And we expect that with a lower number of objectives, we will improve the performance of the genetic algorithm. So after running for a certain number of time, after our stopping criteria for PCA is we will run PCA again to see if we can reduce further the number of objectives. So in the end, we can reach the number of objectives of 2 or 3. But to answer your question, we will also analyze the actual refactoring that we are doing during this dimensionality, using this dimensionality reduction. And then my plan is, when I find the final set of objectives, I will evaluate my refactoring and find the best solution. And then I will keep that set of objectives and run the initial algorithm without PCA to see what is the performance of the refactoring using the genetic algorithm from the start and without using any PCA. And compare the two to see which one will be better refractory.
So, in my understanding, you are not sure about the division of the trees, so you also can find the objective, then you can allow the
Yes, I believe that this will work in practice because in practice, if, like I said initially, what made me really, for example, coupling versus cohesion when I want to do my study. I mean, maybe it's my preference, but if I don't have any preference to have 20 objectives, it will be actually interesting to establish the 20 objectives and then come up with statistical analysis to retain which objectives are really being affected by my refractory.
Yeah, I believe one of the other advantages of this is maybe to reduce the number of solutions in the Pareto form. Because when you start with 8 or 10 objectives, you get hundreds of the solutions in Pareto form. So reducing the number of objectives will have to reduce a lot the number of solutions in Pareto form, and that's one of the main advantages.
So, is there no more questions about the speaker? So, next presentation is by Nisa. We will present this paper titled Big Multiplying Molecular Research for Program Synthesis.
So you have to turn it on.
Hi everyone, my name is Joseph Lin, and my topic is General Program Synthesis using multi-color research. So I'll begin by explaining about the multi-color research. So we've all seen the Cisco components, and the human goal chain capacity used by Google's AlphaGo. And Google's AlphaGo uses this multi-color research to value groups. We decided to apply the same method to program synthesis. So multi-color research belongs to this class of algorithms called multi-color method. And the powerful information is as follows. We have n moves of given states, and we have stochastic rewards that has to be each move. And how do we find the optimal move that returns the highest reward? The information is this. Choose a move, we play many random games following the move, and then we count the number of games that we won and then we lost. And then decide if the move is good, then we are likely to have one more game, and vice versa. So this is a graphical illustration of the process. We have rule A, white, black, and we sample 3 distinct random games following that. And we find that we won 1 game and lost 2 games. So far the evaluated reward is 1/3. In contrast, we have another rule B. Again, we play 3 moves. Again, we play 3 games. And then we have won 2 games and lost 1. So far the reward is 2/3. And we can say that rule B is better than rule A under the current estimation. Of course, in the real situation, we sample a lot more games, thousands of games per loop. And as the number of evaluations increase, the estimations increase. Estimations become more accurate. So how does this algorithm deal with the exploration exploitation trade-off? Well, the trade-off is evaluating. So we have to evaluate a bad action less often to maximize our rewards. But at the same time, we have to evaluate it sufficiently often in case it turns out to be good. So how do you achieve this? So this is a formula that balances between the exploration and exploitation. At each turn, if you have n moves, you choose the action n that maximizes the following statistic. And where x bar n is average reward obtained so far by evaluating that specific move. And p total is a total number of evaluations. Pn is the number of evaluations of that specific move. And k is the parameter that tunes this balance. So if you see p total, as p total increases, this whole statistics increases and makes that specific move more promising. And as Pn increases, the denominator increases, so statistics decrease and makes the move less promising. So the algorithm that we use is called upper confidence bounds applied to trees. It's called, in short, UCT. And the basic idea is to extend this multi-column method to the entire game tree. So how can we apply this MCPS to program synthesis? There are many ways to do program synthesis. The version we did is using the test cases as the oracle for search. As the overview, suppose you want to generate a program that sorts the list of integers. And we have an input, and we generated program 1, which gives some bad output. But the number of violations is 3, and then we generate a better program out of that program. So program 2 has number of violations 2, and so on. It increases, fitness increases until we get the correct program n, which sorts the list of integers correctly. So we're using test cases as a program specification. So how does this have to do with MCTS, which was invented for playing games? So we have the familiar picture, and we have an incomplete program. Incomplete program and the candidate instruction, which is I1. And following that instruction, we sample three random programs as follows. The first program execute properly. So the overall reward is 1/3. So this is how it maps 1-to-1 from the game formulation to program synthesis formulation. So as an overview, at each iteration, we produce a program from a given instruction set. And we evaluate its fitness from the test cases. We direct search towards regions of better fitness. Our natural question is, what instructions should we use? We considered using Java bytecode instruction. So pros, it's simple and easy to execute, but cons is too fine-grained. Too fine-grained and search becomes difficult. For example, if you have to print something, you have to have 3 instructions. And search might get a little too difficult if you only use the Java bytecode instruction. So as a remedy, we use a lightweight intermediate representation designed for our purpose. So each instruction is either a single bytecode instruction, such as I-1, or it's a set of bytecode instructions that provide shortcuts. For example, the iPrint, print a picture, or fprint, print a float. And the generated program is a stack of intermediate representation. Next, how do we define fitness? Well, fitness is pretty straightforward. We define distance matrix per test output. So for integer, float, and character, we use equated distance, and for Boolean, we use discrete distance. For string, we could use Weatherstack distance and so on. And here are the additional details. When we did type checking with the synthesis, we found that this is enormously important because the search space is so big that we have to restrict it using type checking. And second, dealing with control flows, such as if then else, conditionals, or concatenation arbitrary number of statements. For example, 2 consecutive print statements. We also ensure that a program's tag represents a valid program. For instance, we ensure that it always has a return statement. And lastly, we set a limit on the program size so the execution ends with that tag. I'll explain about my experimentation, my experiment 7. So we use 6 program synthesis benchmarks for Hello et al. And they are very small benchmarks designed for program synthesis. And they are add integer floats, compare string lengths, grade, median, smallest, and small or large. So since GP is used widely in the program synthesis community, we decided to evaluate our approach against GP. And for GP, since there was no existing framework available, we implemented strongly typed GP on top of this high evolve. And for each benchmark, we ran it 30 times because there's stochastic algorithms. And here are the results. The first benchmark is add integer and float. It's a simple benchmark. You add an integer and a float, and then you print. This is compared. And most of the times, the 2 algorithms find the correct solution. Next is small or large. Again, as variations increase, the fitness becomes better. Top graph is GP, and bottom graph is UCP. Yeah, compare string lengths. We have 3 strings, and it's a pretty difficult program, and both do not perform very well. But we can see that UCP performs slightly better. Lastly, we have grade. This is complicated. This is a little more complex benchmark. We have 5 integers, and the first 4 represents the lower thresholds for achieving grade A, B, C, and D. The last represents a numeric grade for students. And you have to print the letter grade for the students. It involves like complicated nested if and then else loops, if and then else conditions. So it's a difficult benchmark. But nonetheless, the fitnesses continue to drop. And we have median, obviously print the median. And then lastly, we have the smallest. We have 4 integers and print the smallest. As a future work, as discussion, MCPS and GP show comparable performances. We found that type checking is essential. And third, we thought that considering only the input-output pairs is inadequate because when we reprogram things, we read the natural language statement of the problem, and then we code. And maybe the machine should be given the same amount of information, by parsing the natural language statements. And we plan to do experimentation on more benchmarks, and we will consider instruction distributions for real-world code performance. So as a summary, input-output driven program synthesis iteratively generates a program that produces a correct output given a set of inputs. And then we implemented a program synthesis with Java bytecode instructions and stack representation. And we found that MCPS performs comparably to GP. Thank you. Any assumptions? Would you clarify the word assumption? We haven't checked that much. We haven't checked that far. But we haven't checked that far. Maybe you could investigate further.
So in this program, is it good to use it for similar problems?
Right, benchmark it. They pushed it to solve these benchmarks. And it was a little different because we had like tens of millions of reactor values.
And one of the most important mistakes we make so that we make sure that it's like the best element of the
Actually, the people plan.
so it's already pretty important to do
That has been right. Monitoring is important, right? What I think is more important is what I think is incredibly hard. And I think you have to incorporate that happening.
presentation by Vanessa and
into the protocol running birth evaluation in open source repositories with evolutionary techniques. And this work was developed by the software learning optimization group from State University of Sarah in Brazil. This presentation is one of our examples. Introduction to the knowledge, preliminary paper study, experiments, results, and analysis, conclusions, and future results. So, double specialization is considered a very important and complex task, especially in open source repositories. The reason is these repositories keep a large amount of data and prioritizing a lot of data manually may actually assess. In addition, the music community can have a different interests by the resolution of the data. In order to address this problem, the best propagation problem, a search-based non-objective approach was proposed by Drayton. And this approach is based on user profile of the page area of bugs repository and the information that this repository keeps about the bug as follows. Severity, at first given by the user that reports the bug, priority given by the expert user, and the negative vote given by the user community that is the resolution of the bug. And these bugs are suggested to optimization process using genetic algorithm. And at the end of this process, prioritizing of bugs are suggested to develop. Considering the opinion of the user community. However, the open source bug repository is a dynamic environment where often new bugs are inserted, deleted, or modified. And the static optimization process is many times unsatisfactory because it doesn't realize that changes happen, it doesn't use repeatedly alternate knowledge, and it will be more costly to do the thing. In a way that, arising the follow question. How to guarantee what of bugs take into account the different interests of the user profiles and the tools that happen over time. In order to address this new perspective, we proposed a model based on dynamic optimization. At first, we considered the bug prioritization as a dynamic optimization problem because the features of the bug change over time, and these changes affected the essence of the problem, and consequently, the search space of solution changes too. Thus, the dynamic optimization problem uh, are are solved by the evolutionary dynamic optimization techniques. They are evolutionary algorithms able to react to change, tracking the global ocean. It's interesting because this algorithm is based on biological evolution of individuals, similarly subjected to the environment. To formulate the problem, we consider B a set of verbs available in the repository, and P a specific sort of verbs from set B, and now those tools number of rows RMT3. And the function importance aims at anticipating the resolution of the high priority birds with the RMT3. At last, the function severity aims at anticipating the resolution of the most to evolutionary dynamic optimization approach. The first generic algorithm with representation, where the mutation rate is increases as the change happens. And this mechanism allow the exploration of the new subspace of solution. The second approach is generic algorithm with generic propagation, where before the change happens, the most adapted individual is propagated to the next one. And this mechanism, it allows the user the knowledge previously gained. In our experiment, we used a dataset with 546 birds from cage 80 bird repository, and the approach was evaluated varying hypermutation rate, genetic propagation rate, and level of chance in 30, 60, and 90%, and the period of time in 30, 60, and 90 seconds. And the algorithms were executed 30 times for each combination of perform to answer these following social questions. Is a dynamic approach more efficient than a static one, solving the bug prioritization problem in open source repositories? To answer this question, we evaluated the performance of the three algorithms, GA static, GA with hypermutation, and GA with genetic propagation, by the metric area. This metric expresses an average of the area formed by the best fitness values found before each moment of change. The table 1 shows the performance of the GA static, in which scenario combining a period of time and level of chance. And here, this algorithm has the best results with period of time equal to 90 seconds. However, level of chance. The table 2 shows the performance of the GA hypermute, and in which scenario combining period of time, level of chance, and mutation rate. And here, this algorithm has the best results with mutation rate equal to 30%. The table 3 shows the performance of the GA decropping, in which scenario combining period of time, level of chance, and genetic propagation rate. And here, this algorithm doesn't have a configuration that outperforms on the others. And here, this graphic shows the performance of these algorithms in a specific scenario, where the level of chance equal to medium, and period of time equal to 60 seconds, and the mutation rate equal to 60%, and genetic propagation equal to 60% too. And here, the GA static was better than GA hypermute, but the GA decrop had the best performance of the others. Thus, we conclude that a static approach outperforms a dynamic study based on hypermutation. It's probably because it increases the mutation rate, decreases the exploration level of the new search, the new best solutions. And the dynamic evolutionary approach based on genetic propagate obtained the best performance. And as future work, we intended to use other metrics of performance and implement other dynamic techniques and apply statistical tests. So that's it. Thank you very much.
Questions? Asking questions is very important.
How we simulate the balance. We developed simulated the insert chance, the this distance. We have one moment. We have a stance with 146 volts, right? And we developed simulated that chance. For example, in which 30 seconds, the simulated chance can budge, can 30%. That budge. In a second, in the next 30 times, 30 seconds, the
Yeah. My question is more around the dynamic evolutionary algorithm that we're using. So because in that area there are two maybe possible levels of uncertainty or so my understanding that you are changing the priorities over time and you see the impact of that in your search. But at the same time, there are some other areas where your fitness function could change over time. So it's non-varying fitness function, which could happen here. It's not just a matter of that the priorities of your diet change, but also your fitness function could change over time as well. So are you trying maybe to try to maybe address this as part of maybe future work, that maybe your fitness function will depend on the type of the diet that you are addressing, and if the type of the diet are different, so maybe you can change even your fitness function over time.
do you say about the benefits?
Yeah, I'm talking about the fitness function itself, because, for example, you are giving weight to the different, factors that you are using or criteria to evaluate your solution. And maybe this weight could change over time. So can you dynamically update this? Because this is one of the advantages of using dynamic optimization.
I'm sorry. Okay. Thank you very much.
Okay, thanks.
Could you repeat, please?
I cannot hear you very well.
Maybe there are some correlations between words. If that's a word, maybe some other words could be fixed or it's happens. And if it's a verb, if there are any other verbs that can be fixed, maybe find the group of verbs and contribute together. We can more priority. No.
The people really use this above as only this word. We don't commodities or the payments, the payments, not
Questions? More questions? So you are using this in the discussion that combines importance, relevance, and I think it is relevance and importance.
The relevance is expresses how relevant the belief are. For example, each the birds have a vote, received a vote, and this relevance is measured by the value of the number of votes, and the importance is the priority, and priority is the value given by the expert reason, and severity is given by the use that reports the name.
Even there is a correlation between importance and relevance. So these two entities are related.
the relevance is saying that the community say they have the relevance of doing votes for this word needs to be used. So this vote is counted and I know the relevance on this. The priority is seen by the effect of the prior item is saying the importance of the severity.
What is the next step?
We need the implement the mechanism for hypermutation, because hypermutation low is bad, but hypermutation high is bad, low is bad too. So we have found the point correlacionado correlated to impact the change.
Okay, so let us thank our speaker. So next presentation by Dr. Roque, and it's about human resource allocation in software projects based on task similarities. Our next
You have to click on play.
So, hello everyone, my name is Rupert Hockey. I am a master degree student at State University of Ceará in Brazil. This work was done with the help of our Alex and my advisor, Jackson. The name is Human Resource Allocation in Agile Software Projects based on task similarities. A brief agenda for my presentation. Firstly, we're talking about a brief introduction, followed by a proposed approach, preliminary experience, and then conclusion. So, human resource management is a key point in a project social management. And a failure in this point can mean a failure in a project as a whole. And we have a lot of ways to manage our development software. So one of these ways is the iterative development that is used in the mostly agile methodology. A lot of problems surrounded the management of the project. And one of them is the resource allocation for software release plan for resource. These problems is the difficult to say who the developer will execute each task in the project. So each developer has different characteristics and different skills. So I need to say who is development will develop each task. Another aspect that we believe that we need to consider in our allocation of a task is the similarity in requirements. So we believe that if I provided to our developer a set of similar tasks, this productivity will be increased. So the main idea of this paper is proposing a multi-objective approach to solving the problem of DevOps, providing automated solutions that assign tests compatible to the developer in a set of similarity tests, finding to minimize the cost and the time of each release and the project as a whole. At this time, our proposal is basically a lot of math formulas. So right now I don't have how to explain this format with details, but if you are interested, you can see in the paper. So our project is based in one methodology. So this one is divided in three. We have a set of tests to be developed and a set of employees responsible to develop them. Test has a estimated hours and a matrix of required skills of them. And the employees have our value by hours for him. The price of it is extra hour value. I standard workload into the speed over time into the speed and use the skill of my skills making. Our approach uses 4 auxiliary structures. It's the similarity method. We keep the similarity between all the requirements. Three vectors, which is the hour value, the extra hour value, and the workload of each employee. This is represented by integer vector, which where S and X size represents the employee. As I said previously, our approach is limited to two aspects. In the second cost. Because the time, there are two things and influence the time to development to develop a test. The efficiency. So the EFC factor function is responsible to say how efficient is our allocation. Automatizing the employee skills by the employee testing the develop the test. The similarity. The efficiency is employed by test. The similarity is test by test. How similarity is a set of requirements attributed by to other developers. So the efficiency and the similarity, we now can say how the time of the total time of the solution. And we do this, the estimated hours of each test in the solution influenced by the EFC factor to the C factor. It's a very similarity. Because the efficiency can increase and decrease time of estimated for a test, but the similarity only can decrease. We have alpha and beta to use the weight of the efficiency and the similarity respectively. About the cost. So I know a cost of a solution, we first to know how many hours each employee works. And we do this with the function estimated hours. The behavior of this function is similar to the function time, but the difference is that here we only do the calculus for employee in specific. When I know how many hours he works, here I want to know the value of the value for the solution. And if he works only his workload in the screen, I simply multiply the amount of hours for the value of hours. But if he works more, the value that passes will need to be multiplied by the extra hour value. And then with the function cost, I do all this, the value hours, the estimated hours, I do this for all the employees, and I have the cost of solution. And our multi-objective formulation finally is aims to minimize the time, minimize the cost, subject to two restrictions. The first one is the estimated hours from an employee cannot be more than his workload, but plus his maximum overtime. The other one is if a test required one specific skill, an employee who doesn't have this particular skill cannot be allotted to this test. We've done some preliminary experiments, and at this time we just compare algorithms to know the viability of the approach. So we study a distance. The first one is the dataset one is from a pre-order sales system. The second one is from a software of management community. In first dataset, we have 32 tests and 5 employees. In dataset 2, we have 25 tests and 3 employees. We executed 100 cells, so check the sanity check, and 2 evolutionary algorithms, the NSPI2 and the MOCEL, configured by the same way. And we use 4 skills, the ability with interface, logic, SQL, and test. Each algorithm was executed 30 times, and to evaluate the results, we use 3 methods: generation of difference, spread, and hypervalue. We realized a statistical analysis to if the first one was good quality. For check, it was statistical difference in the three samples for the 3 algorithms. Then we made a report and a variable analysis to a pirate comparison. The first one to check if a statistical difference in variable analysis to measure the effective size. So, the table was not too big. I think it's something with slider office, but I think you can see. But in cells in orange is where the NSK2 was better than MOCEL. As you can see, in both datasets, the approach behavior similarity. So the NSK2 was better in hypervalue in general distance, and the MOCEL was better in spread. Comparison the random search with the 2 evolutionary search, the random search outperforms NSI2 and MOCEL in spread in all comparisons. In conclusion, the management of human resources are key components for a software project management. We propose a multi-objective approach to human resource allocation, and to reduce the time and the cost, allocating compatible and similar tests to the resource. The NSR2 cost development data, and we continue work and the continuous development now and try to automation for the estimated of similarity in the requirements, and to extend the experiment, mostly to check if the similarity, the gain if you have using the similarity to the allocation, and for application for multiple teams. Right now, if we have one team, I can apply the approach, but if it's not working for multiple teams working on in the same version. Okay.
Questions?
Yeah, I have to maybe about the data set. So did you collect that from projects from different contexts, or it's the same context?
2 projects from the same company, but it's 2 different. The first one data sets, it's a system in production. The first one is a whole new system was development. It it's developing right now. It's different from the data set.
And are you planning to compare with the current practice used maybe in these companies,
Yeah.
like the current scheduling?
It's one thing that we need to decide, because we want to apply this for multiple teams. If we do this, we cannot use more these two data sets because the two are small. So we need to decide if we do this. If right now, if you don't, we will increase the experiments, doing comparison with the two data sets with the current approach, and try to measure the significance of using the similarity between the requirements. And from this, we will compare with the current approach.
Okay.
Any other question? So in your form of condition, you have these classes and these employees, and you want to assign classes. One class should have one,
No, that's an employee can take one or more tests, but one test is going to only one employee.
and you consider the workload, sometimes you have more employees and perform this task, but maybe
Yeah, that's right. Yeah, we consider this. We have the workload and the maximum overtime that we can job. The people cannot do it manpower by this. So we consider that this. So maybe a guy has the skills but to develop the test, but someone else can do the test but cannot do the test that is assigned to them, and we do this back. Yeah, this is the first next step is to increase the experiment. Yeah, that's right.
Any more questions?
Yeah, perhaps this is one reason that we have interactive approach. Like we can put we can use the in general the software engineer will be relevant to use all automatic solution. So you can put him in the process. So for this we use iterative optimization. We can put the software engineer in the process and use these maybe some subjective thoughts that happen we had. I don't know, maybe someone to go out the company and to do this before goal. So we can use the kind of objective on putting the software engineer in the process.
8 p.m. in the of course the hotel. So and also we need the work announcements for 2 weeks of the the best way to work and also best sound way to work and also the best review to work. So that's to be so see you later.
Yeah, we can. But you don't need to take the screen. Yes, it's the one where we had lunch yesterday.
Where was it? Yeah, yesterday we served them.
Yes. Yeah. So and we put the table for the
包括设计师他对你这个大家的意义。
Yeah, we have not talked about how always busy. How are you doing? Good, how are you? Always, he's
Yeah.
he's PM and he's now is
Two hours less. There's have to do 2 hours more.
but you don't get to work on the science.
Yeah, I thought that I noticed that. You know, that's how you can help so you cannot let them try things that you're not sure if it's going to work. Right? You always have them in your direction. Also, the time is right. You can no longer have room for crazy ideas unless you have the time for them. Right. Or students, you can do whatever you want. It's interesting. I will keep on.
Right.
How about you want to go with me, an alley?
Yeah.
I will go with
They can ask me for the money.
the